SQL was a mistake, although I absolutely love this declarative language. I still think part of the SQL design must have included undeclarative ways of getting to our data. Let me explain. So, what is SQL? Structured query language was designed years and years ago for users who don't care about the underlying structure of how the database work and just say, hey, give me that data, which is a very useful tool. Very, very useful. If give me this particular field from this table, satisfying a certain workload. If you believe it, yes, SQL was designed for normal users, not developers per se, because that was the closest thing we could build as a user interface back, way, way, way back. But this idea of hiding the complexity of how things work and presenting you with a dish that is ready is to the detriment of people who need to know what's going on behind the scenes. If you are a normal actual user and you didn't build the product, that's a different thing. But if you're a developer, if you're a backend engineer actually sending those SQL statements to the database, it's not a good idea to not know what's going on, because SQL is an abstraction. It just tells you what you want and it gives it to you. You don't tell it how to get that thing, unlike any programming languages out there. Right? So that idea of declarative, just declares, what do you want and I'll give you. So that declarative aspect makes it easy, but at the same time, it's a double-edged sword. And the main problem is it's unpredictable in performance because it was designed for that main reason. The database has to do a lot of work to produce an execution path or a plan to derive the result, where that developer who sent that query have absolutely no idea what that path or control for that matter. And that is the problem I have with SQL. As a language, when you don't have control or you don't know what's happening, when you send a query that looks benign, that looks simple, and it takes a minute to execute, that is when you start scratching your head. It says, well, why is it taking a minute to execute this SQL statement? And you have absolutely no idea, because the planner picked a plan that happened to be very, very slow and bad. And that is the main problem here. So the idea of hiding the implementation always comes from the idea of abstraction. Abstraction was designed to, don't worry about what's underneath. Just tell me what you want. Abstractions always, always, always leak. And they leak in these unpredictable ways. I would execute a SQL and the database was configured with this idea of of parallelism. So it will spin up 5 threads, unlimited threads, to satisfy your query because it can chop them up, because you built it in a way that is very expensive and you didn't know why, of course, because how could you? The SQL is so simple. So it started spinning threads and stuff like that, and then all of a sudden, yeah, the query came back in 30 seconds, but it took 100% of all your 8 cores to do so. Now think about that. Execute the same query by multiple users and your database is toast. The CPU becomes 100% because all of these threads becomes this part of unpredictability. And these are just few examples of what could go wrong with this SQL. So why am I ranting about that? I love SQL, don't get me wrong. I of course, use it every single day in my life for 20 years. So the problem is, and I'm not blaming some databases do this, but the SQL should have came up with a spec that allows you to choose a path for those who are kind of nerdy enough to choose a path for their execution, period. And most databases actually realize that. Oracle realized that, SQL Server realized that, I don't know about MySQL. Postgres, they're very, very hesitant to do that. The idea of hints. Just tell me what path should you take. SQL Server is one of the powerhouses. Say anything you want to say about Microsoft, but they built a fantastic database. I love it. You know, just all these tweaks. They have so much tweaks. Postgres is getting there, but it's not remotely close to get, because it's open source, right? But man, there's a lot of work for Postgres to get close to Oracle and SQL Server. When you actually work with these beasts of databases, yeah, there's so much. You need this fine level control of things, these hints, and Postgres refuse to add hints. So you have to jump through hoops and extensions to enable hints. And hints are this idea of just let me choose. I know that I'm just created this table. It's gonna be empty. It's not gonna have more than 1,000 rows. Trust me. Always gonna be that. I know as the application author, I know more than you. The database don't know shit. Databases don't know as much as the application. The databases claim to know by doing this statistics, but these are just statistics. And they can be just like that, out of date. The application, of course, if they know what they're doing, the backend engineer here specifically, because we are the number one user as backend engineers, we are the number one users of what? Of databases. Yes. So give us these tools, please. So yeah, if you want to have this level of control, you can, using hints. But unfortunately, I wish that was built since day one in the SQL standard. Yeah, so the application developer or the backend engineer knows exactly how they more likely, hopefully, let's say, built the database schema, built the indexes, and they know the path that the query should take. And they would choose a consistent path over performance. And if there is like, if I'm gonna sacrifice one query over 1,000 different query, and I change something to make that query faster and the rest of the platform slower, the developer might choose to be consistent. I'd rather pay an extra half a second here and be consistent across the board than this unpredictability. It's like, oh, he executed once and it takes 15 seconds. You execute it again, it takes 1 millisecond. That is the worst thing you could happen in database programming, in my opinion. Of course, this is debatable. All of this stuff is debatable. But in my opinion, I choose consistency. Of course, consistency comes with performance choices, but that consistency is when you give me the path. I know, trust me, I know what the path should be. Allow me to do that. So that's my problem with SQL. And now we do have non-standard way, like SQL Server gives you this non-standard way to do almost everything, even to the way the index is being scanned. Yes, to the way the index is being scanned, you can choose what path to take. Can you imagine? I want to talk to the designers, the architects of SQL Server, like what made you add that choice? I bet you there is an enterprise customer who ran into this unpredictability and they had to add that feature. And that's why it's like, if you don't know, I primarily work with enterprise companies, so closed source, custom data doesn't ever get back out, larger transactional volatile system. None of this cooked cached stuff that Google you add something and it shows up like three days later. No, none of that stuff. It's the transactional, just like that. And you have to be a transactional system. Working with enterprises is a different beast. That's why Google doesn't really go there as much as they do, right? It's a different beast. But yeah. So that's what I want to talk about. So when you're writing SQL, the idea of abstraction is more like it, right? The idea of abstraction is always, when you try to summarize this video, when you try to simplify something, it will always backfire for those people who actually want to know what's going on behind the scene. For those who absolutely don't care and they will just outsource the job for someone else, that's a different story. But for us, who actually the expert who wants to fix this software, they need this flexibility. Same thing with the example with the car. Like, I don't know anything about cars, but I would delegate that job to someone who is just their bread and butter. They love cars. They love designing cars. They hear how a car sounds like. They know exactly what's going on. That's their bread and butter, right? So to them, they have even preferences. Same thing with building computers, right? People have preferences. People have, like, I wish this is this way so I can build a better system. You know, it's just every path you take, there's the abstraction should only exist when it's necessary, but there's always should be a path where you can see behind the curtain, where you should see behind the carpet. You can see everything. Hiding details only backfires. For the experts, if you want to become an expert to something, you really need to just tear off all those abstractions and dive deep and understand everything that is of the thing that you're passionate about. And boy, you're gonna look at databases completely differently. I love this stuff. I'm gonna see you in the next one. You guys stay awesome.